Okay, once again, guys, good morning and welcome to this last session with round 2 2021 training program. Um, we will move immediately into problems 20 to 25 because those are the most difficult problems, and we are trying to finish as many problems as we can today. So there has been a request that we do the difficult problems first. So let's go straight to those problems. Okay. So we now look at problem number 20. Problem number 20, it's a sum of a number of terms, a finite number of terms, as you can see, and the denominators are all sums from 1 to n, where n ranges from 1, 2, 3, 4 up to 21. So, well, for each of those denominators, we already have a way of calculating those formulas. So just let's just recall these two important formulae. 1 plus 2 plus 3 all the way up to n plus n, right? You all know what that is. If you don't, then you have not learned something very important in this training program. It's n into n plus 1 over 2, the product of two consecutive numbers divided by 2, where the first is the smaller, the smaller is the number of terms. Okay, now there is another one which I will just write down because it's useful. Okay, maybe I'll do that when the time comes. So what happens here is you got 66 times. Okay, so this is, well, 1 over 1 is already easy, but I just want to get the formula right. It's 1 over 1 times 2 over 2. That's your 1 there, right? And now this is 1 over, now it's 2 times 3 over 2. I'm sorry, this is not 1 over that. And then that is 1 plus 2, which is 3. And you can see this is going to be 3 also. Here it's 1 over, it's 3 times 4 over 2. That's 1 plus 2 plus 3 gives you 6. And 3 times 4, 12 over 2 is also 6. So it goes on like this. And here it's 1 over 21 times 22 over 2. All right, so you can see now you got denominators are all fractions with the same denominator right throughout. When you invert it, you're going to get 2 going to the top, all over, right to the top. So I'm going to take the 2 right out and make this 2 times 66, which is 132 times. And now you have 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 21 times 22. So when you invert it, the 2 goes to the top, the numerators still remain at the bottom. Now you see you've got these kinds of things at the bottom here, where you have things like 1 over n into n plus 1. See? 1 over n into n plus 1, where n runs from 1, 2, 3, all the way up to 21. Now, there's a very important identity involving this, and it has appeared in previous Olympiad problems, and that is, you can write this as a difference. You can write this as a difference of 1 over n and 1 over n plus 1. The difference of two reciprocals, consecutive reciprocals. If you simplify this, you will get precisely that. So I'm going to write each one of these in like this. So it's 1 over n into n plus 1 is 1 over n minus 1 over n plus 1, where n is a smaller. So if you look at this now, you get 132 times. Now, this is 1 over 1 minus 1 over 2. This thing here is 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4. You go on and you get plus 1 over n, 1 over 21 minus 1 over 22, right? And now you see, lo and behold, these guys disappear, what I call, they commit fratricide, brothers killing each other. And the 21 also disappears. And in the end, you just simply have 1 over 32 into the 1 survives. And this last one survives, minus 1 over 22. And when you work this thing out, you get 1, if you expand it, 132 times 1 minus 132 divided by 22. And that gives you 126. So the answer to that problem is 126. All right, as you can see, it's a challenging problem. It asks you to know 2 important things, which you should have gained from previous doing problems in Olympiads at some other time. Okay, so let's get on to problem number 22. Now, why is this? All right, we are now at problem number 21. Problem number 21 is a nice geometry problem. What you have here, the lengths of the legs of a right angle triangle are 18 and 63. So, all right, you've got a right angle triangle and the lengths are 18 and 63. So the shorter one is 18. Let's just record that in the diagram. So this is 18 here, and this is 63 here. All right, of course, it's a right angle triangle. And you got a circle here. We don't know where the center of the circle is. It's somewhere along the hypotenuse. That's what we know. But the circle is tangential to the 2 sides of the triangle. It's a nice circle which is sitting comfortably inside this right angle triangle. And the question is now, what is the radius of the circle? What is the radius of the circle? All right, obviously we have to make some constructions here. You can't find the radius immediately, but the construction will be, well, these are tangents. So naturally we have to join the center which is given to the points of contact. That will be a radius. And there's another radius here. Okay. Now, a tangent to a circle is always perpendicular to the radius at the point of contact. So these are 90 degrees. And we'll call this is your unknown, your radius R. Both of them are. Now, if you look at this picture here, you've got a quadrilateral, 3 of the angles are 90 degrees. So therefore, the fourth one is also 90 degrees. So this thing here is a rectangle. But more than that, it's a rectangle with two adjacent sides equal, right? And therefore, it is necessarily a square. So you got these two sides are R. Right, now the problem is now to get some equation involving R so that we can solve for R. Right? Mathematics is full of problems which end up in equations which you have to solve. Okay, the whole thing is 18, so at least we can make some progress here. This part here is 18 minus R, because the entire line is 18. And likewise, this is R, and the whole thing is 63. So this part here is 63 minus R. All right, so you got these two right angle triangles, and you know there are two of those sides, of course, also the third one because they are right angle triangles. And can we now find the radius? Well, there are two ways of looking at it. This angle here, let's have a look at that angle. We can call it theta. It's the same as this angle here, because these vertical lines are parallel, and these are corresponding angles. Okay, and now you have, I'd like to go on to use trigonometry because you guys are senior students. And trigonometry says that you can find, you got two sides of the triangle, R and that. So we know the tan of theta in the top triangle is R over 63 minus R. And then we exploit the fact that the theta is also in the small triangle. And here the tan of theta is, again, you can get it. It's 18 minus R over R. All right, so there it is. You've got your equation involving R. And you can solve for this, for that equation. Okay, I'm not going to spend too much of time with that, but I'm going to do it very quickly. Cross multiply R squared 18 times 63. I'm not going to simplify that. And then you cross multiply, you get minus 18R minus 63R, which is minus 81R. And minus R times minus R is plus R squared. And happily, the R squared cancels, right? You can take the 81R into the other side. No calculators are allowed. So you can divide by 9 and you get 9R. Divide that by 9 and divide the other by 9 as well. To get 9 times 9 is 81. And without any calculators, you can get the final answer is 2 times 7, which is 14. All right, so here we have a nice problem in geometry, which wasn't too difficult, I think. Let's just pause. How many of you got R equals the radius to be 14? Let me just stop share. Okay, we got 20 people. Can you just show by raising your hand, connect to that thing which calls reaction, and raise your hands. All right. Good. We've got 2 people who did this, which is a difficult problem. All right. We are now going on to problem number 22. Problem number 22 says Joe has 20 liters of each of 2 different solutions of salt. The concentration of solution A is 20%. All right, you know, in situations like this, we normally draw diagrams quickly. Let me just draw a diagram. So you got containers of salt, solution. Okay, concentration, there are 20 liters. So this, imagine this thing here is filled with 20 liters of brine. Salt water is sometimes called brine. Okay, and this is your A. And container A, 20% of container A, it's got 20 liters, has got salt in it. Now 20% of 20 liters is 4. So let me just separate the salt from the water and put down that you've got 4 liters of salt and 16 liters of water, because you've got 20 liters altogether. And this is your A. That's your container A, which has got 20% salt in it. Now container B has also got 20 liters, because Joe has got in 2 different solutions. So this is also got 20 liters. So just let's examine what's going on here. Still got 20 liters of salt, but if you look further down, you see that the solution of salt has got 45% in it. This is much more salt here. The solution B has got 45%. Now 45% of 20, 45% is 45 over 100, 5 goes into it, 9 over 20. So 9 over 20 of 20 is 9. So you've got 9 liters of salt and 1 liter of water. So that is the initial situation. Now, the question is, how many liters of solution B? So from here, you're going to take out some of the stuff and you can add it to 10 liters of solution A, right? So I'm going to reduce this and I'm going to take some stuff out from here. I'm going to add it to that and mix it up. Mix up these 2 salt solutions. And I want the final solution to be 30%. All right, so that is the question. So let's just put a new diagram here. I'm going to put a biggish diagram. I'm going to record a lot of pieces of information here. All right, so you got stuff which is moved over from solution B. It's coming from B. How many liters of solution B must be added to 10 liters of solution A? So you got solution A sitting inside here, but you only got 10 liters. So it's just half the number, half the amount. Half of it is full with 10 liters. Now I want to track the amount of salt here. The amount of salt in 10 liters, if the amount of salt in 20 liters was 4, then the amount of salt in 10 liters would be 2. So in this 10 liters, you just have 2 liters of salt and 8 liters of water. So the salt here is 2 and water is 8. That's what you had originally. Now, you're taking some stuff from B, right? We don't know how much. So let's let that be our unknown. So we're taking X liters of B and we are putting it into this. Now, I want to track how much of salt is there, Because to calculate the concentration, I need to calculate the concentration and equate it to 30%. So that's where my equation will come. To calculate the concentration, I need to know the total amount of salt in this new combination, right, over the total amount of liquid altogether. That gives you the concentration. So I want to know how much of salt has been put in here. Now, according to this figure here, we had that 9 out of 20 liters contain salt. Now, what does that mean? I want to find out what happened in 1 liter. So 1 liter of this mixture will contain 9/20 salt. So 9/20 liter will be salt, and the other 11/20 will be water, and that gives you a 45%. Okay, that's 1 liter. Now we are moving X liters across, so therefore the amount of salt you're moving across is 9x over 20. Right? The amount of water you're moving across is 11x over 20. So I'm going to put that down here. So the new amount is 9x over 20 salt and 11x over 20 water. So now we've got a good idea as to what this mixture contains, the total amount of salt and the total amount of liquid. So we got the full profile of this liquid. So now let's just do the calculations, because what we are saying here is that the amount of salt in this new setup is 30%. So that gives us the equation, and the equation that we're going to write down is the total amount of salt we've got in this liquid is 9x over 20 plus the 2, which was there originally, and then that's the total amount of salt. And the amount of liquid is, well, originally we had 10 liters and we added X liters from B. So the total amount of liquids in this thing here is 10 plus X. Now this is equal to 30%. 30% is 3 over 10. 3 over 10. So that's your equation, and we need to solve for X. Okay, from this point it's easy. If I cross multiply, I got 10 times 9x over 2. 10 times 9x over 20 is 9x over 2. 10 times 2 is 20. 3 times 10 is 30. 3x. And you got 4.5x minus 3, which gives you 1.5x. Take 10 to the other side, and then you have x is equal to 20 over 3. Now this is most unsatisfactory, because the answer is supposed to be a whole number. But the question that I got here, apparently I got the wrong question. The original question said, the question that you got, please confirm this, says that round off to the nearest liter. Is that what you had in your question, your original question? Do you remember?
Yes, Prof. But they said we must round the answer to the nearest integer. That was the correction or something.
Okay.
I believe.
Okay, so to the nearest integer.
Yes, at my school as well, we needed to round it off.
Yeah. So this was a round off problem. I think somebody seemed to have messed up, and but they corrected it later on to say round it off to get an integer. So this is approximately 7. So the answer is 7. Well, not round approximately, but rounded off. Okay, so that is the problem answer to problem number 22. Anybody got 7? I would be interested to know. Looks very unlikely.
I don't remember, sir.
Towards the end of this thing. A lot of time is spent in the early questions. I think, and Patrick, I don't know whether Patrick is still here, but this is one of the things I'm going to propose, that we're going to increase the time of this from 2 hours to 3 hours, or maybe 4 hours as well, because this time given is too short for 25 problems, which are extremely demanding. I take about 8 or 9 hours to solve them, for your information. All right, now let's get on to the next problem, which is problem number 23. Now problem, okay, this is my solution, as you can see. I'm going to send you all the solutions. All right, this problem, the next one. Okay, here you got 5 circles which are all tangential to 2 lines, making an unknown, the 2 lines are slanted at an unknown angle to each other, but they're all tangent to each other. But what is given is that the radius, 5 circles, the radius of the largest circle is 288. Let me just draw the radius. So the radius of the largest circle is 288. I'm not going to put that number down because we've got lots of other radii here. And the radius of the smallest is 128. Okay. And the question is, what is the radius of the middle circle? Now, this is another example of a problem which takes a long time to solve. It took me a very long time, and I had to develop a formula for this. So I'm going to do that because it's quite clear that we have to move from one circle to the other. So I'm going to give names to the various radii. I'm going to call the smallest radius R1. The next one R2, R3, R4, R5. We know these values. R5 is 128 and R1 is 288. And R1 is 128. Okay. So I've got R1 here, and here I will have an R2. Like that, that's R2, and that is R3, and this is R4. Right. Now, when you connect these 2 radii, that is going to be R1 plus R2, this length here. In fact, all these points, they lie on the same straight line, all these centers. All of them are equidistant from these arms. Every one of these centers are equidistant from these 2 arms. And there's a very important fact in geometry, which is probably not emphasized enough, and that is concerns the bisector of the angle, the bisector of an angle, the bisector, this thing divides this angle in two equal parts. And the theorem, the fact in geometry, probably is a theorem in some countries, is that any point on the bisector, its distance from the arms are equal. Right? Perpendicular distance, when you say distance from a point to a line, you mean the shortest distance, which is the perpendicular distance. So the perpendicular distance to these arms are equal. You'll find this thing in my book if you go and check in the geometry section. And these two triangles are congruent because these two angles are the same. These are 90 degrees, you've got a common side and so on. They're congruent, right? And that is why they're equal, okay? And conversely, if these two are equal, if the distance are equal, then the point lies on the bisector of the angle. That's the converse. If you got a line and you got a point on the line which is equidistant from the two, that line has to be the bisector of the angle. So all these have that property, so they all will lie on the bisector of the angle. This is just an aside, right? We don't really need it in the proof, but I just thought I would tell you for your own information that all these centers lie on the same straight line. Okay. Now I'm going to analyze the relationship between this thing here, these two radii. I need to get to this radius. I want to find out whether there's any equation which links up these radii. Now remember, you got this line here is R1 plus R2. It's the sum of these two vertical lines, right? And I want to see whether there is a linkage between those two. So to that end, I'm going to go on to the white page, because I don't have enough space. What do you call that? A whiteboard. So let's go to the whiteboard. I'm going to share the whiteboard with you. All right, so what I've got here is I'm going to analyze this setup here. I'm going to put we had this horizontal like that, and then we had a thing is going up like that, and then we had a vertical line, another vertical line, okay? And in the first diagram, we had R1 and R2. I'm not going to call it R1 and R2. I'm going to call it A and B because there are quite a few of these I'm going to apply this to. So you got A and B, but the important thing is that this part here is A plus B. The important thing about this is that is A plus B. And I have this vertical line here in between. Oh, actually, what I'm going to do is let me, just one moment. I want to just look at my solution. Yeah, I'm going to do a little bit more than this. Sorry. Let me just repeat what I'm going to do. I'm going to look at, we'll go back to the previous screen. Okay. Oh, I seem to have wiped out everything from here. But anyway, I've got this radius. Just one moment. Manipulating with this pen, I got this vertical line, this vertical line here, and this vertical line here. So I am going to use the fact that all these three lie in the same straight line. Right, so what I said was not irrelevant before. They all lie on the bisector. And I'm going to analyze this diagram here, right? I got that this is A, this is B, and this is C. And what I'm going to do is try to find out the relationship between these radii. I'm going to aim towards that. Okay, so that is the goal. And I'm going to go back to my whiteboard. I hope that hasn't been wiped out. Oh, it hasn't been wiped out. So I've got that situation. And then we had that this was A plus B. And this was B plus C. Well, actually, we were joining the centers. Sorry, this was A plus B. And this was B plus C. Those are the centers that we were joining. Okay. Now, given this scenario, I want to find out what is the relationship between A, B, and C, right? And we can do this by performing a construction, namely draw a line which is parallel to the base, like that. Okay, and then you will get two triangles which have got the same angles, the small one here and this large one, right? Because these are parallel, right? And therefore we can use trigonometry to work out ratios, and that will give you some equation involving A, B, and C. All right, so let me just unpack what I've just said. What I said is that when you draw these, I have an angle here like that, and you can work out this length from here to here. It's equal to B minus A. This small piece here. The whole thing is B, and this is A, right? And likewise, the small piece here is, the whole thing is C, and that is B there. Oh, wait a minute. I have to draw another line. I have to draw another line here. There, like that. And now the piece that we're looking at is this part here, and that is, let's just take this thing out. That is the small piece here is the whole of C minus that, which is going to be C minus B. Now remember, the goal is to get some relationship between involving the ratio, the radii, and that is what I'm trying to do. Okay, now I've got this angle here is theta, and this angle is also theta, because these lines are parallel. Okay, and therefore we've got the ratios, the tan of both these angles are the same. So you got B minus A over B plus A, that thing there, is equal to C minus B over C plus B. Right. And after simplification, I calculated, and you can do the same thing. I will send you the notes. You get this beautiful relationship that B squared equals AC. Okay, which is very, very nice. You got B squared is equal to AC. So if I go back to my diagram, so what we are saying here is that, we'll go back to my diagram. Right? What we have is that I said that these vertical lines are R1, R2, R3, R4, R5. So we're looking at R1, R2, and R3 as your A, B, and C. And we are saying that B squared, the middle one, squared is equal to the product of the other two. The middle one squared is equal to the product of the other two. So we have R1, R2, R3, R4, R5, and you can set up a lot of equations like that, okay, which I'm going to do now. Okay, so we have these lines here. Let me just do this. Now we have 5 vertical lines. These are all these are equal to the radii. You're joining the centers to the baseline, and these lines, their lengths are R1, R2, these are various radii, R3, R4, R5. Because these things are rather messy, I might as well call them A, B, C, D, E. I'll use A, B, C, D, E for R1, R2, R3, R4, just to make my life a little bit easier. All right, now we have the following equations. I want to link up A and E, because those I know. I know the initial radius and the final radius. All right, okay. How do we do that? The middle one, B squared, is equal to AC. I finished with this. Now, likewise, C squared, this thing here, is equal to BD. It's the same scenario repeated, right? These are adjacent circles. And here too, you've got D squared is equal to CE. So here again, you got the same scenario repeated. The middle squared is equal to the product of these two. I want to link up A and E. And A and E occur only in the first and the last, right? And the way to link them up is just multiply these two things and see what happens. So I'm going to multiply these, the first and the third. Now with AC squared E. I'm multiplying that and that. That will be equal to B squared times D squared. Right. And B squared we know is AC. And D squared Oh, wait a minute. I'm going around here. Um, I know. The c squared has to be replaced. C squared is equal to BD. Right? And then you have the BD occurs twice. So you have AE equals BD. But BD is C squared. Right? BD from here is C squared. And there you have it. That this middle one squared, right, that's your R3, is equal to the product of the first one and the last one, which is R1 times R5. We know these. This was given as 128 times 288. And that's the square of R3. So you take the square root. This is 2 times 64. And this is 2 times 144. So R3 is just equal to, this is R3 squared. So R3 will be 2 times 8 times 12, which is 192. So that is the long and the short of the story, guys. Okay, I would be extremely surprised if anybody has got that out. It's more like an IMO problem, something like that. Whatever, but it's quite a learning experience to go through this thing. I'm sending you all the solutions, so you can take your own time and try to understand this solution to this problem. All right, let me just ask you guys whether you are, what you feel about this problem. So what's your take on this problem, guys? It took me a long time to solve it. No comment. All have been awe-struck. All right. Okay, TK.
Yeah, Prof.
Okay, TK tells me he couldn't solve it. Okay. I
Yeah,
think
Prof.
Good. It's a good one, Prof.
you think it's a good one. Maga says
I
he
think-
thinks it's a good one.
Yeah, but I don't know how I did it, but I did it in 2 lines and got the same answer.
All right. Okay, Maga, you just took a wild guess and you got
I don't know.
45.
How, I think there's
Okay,
there's a
Maga,
flaw
can
in
you,
there.
can you stop talking? I'm going to carry on with my class. All right.
Okay.
Now, let's just go back to our whiteboard and go to number 24. That's the next problem. Okay, problem number 24. Problem number 24 is a geometry problem. And let's see what it says here. It says triangle ABC. Oh, you got a triangle ABC, and they say D, E, and F are 3 points. They don't tell us anything about D, E, and F, whether they're midpoint or what. Okay, anyway, they join a couple of these lines, but they do say that D divides AB in the ratio 2:3, as you can see here. So this is 2 parts and this is 3 parts. And then these things are joined, and they tell you something else too. They also say that the triangle ABE triangle ABE ABE is equal in area to DBEF. So that's quite a complicated thing. This triangle here is equal in area to that one. All right. Actually, this problem is not so hard if you know what the construction is. And what I did was I joined DE. I think that might be a natural thing to do. Now I've got this entire triangle split into triangles, right? And the quadrilateral under investigation, the quadrilateral under investigation, this one here, is the sum of two triangles here. So let's call now we give names to the areas of these triangles, okay? Because we are told that the area of a triangle is equal to the area of a quadrilateral. So I'm going to call this A, B. I'm going to give names to all the areas. B, C, D, E, F. Let's give names to all these things. Now we are given that the area of triangle ABE, there's ABE. So we're given that A plus B plus C, that's ABE. ABE is made up of three triangles, A plus B plus C. And that is equal to the area of quadrilateral DBEF. So you got D, B, E, F, and that's A plus B. Oh. Oh, no. Oh, the quadrilateral that it's equal to in area is DBEF here. So it's A plus B plus D. Okay. And something very nice happens here. These guys, they, as I say, commit fratricide. So C is actually equal to D. These two are equal. So that's very nice. That these two are actually equal. So I can replace this D here by C. And then you see that this whole triangle here, its area is C plus F is the same as area of this triangle. So I just want to isolate these. You got the area of this triangle here. Oi, sorry. So the area of that triangle that's C plus F is equal to the area of this other triangle here. So let's just focus on these two red triangles. These two red triangles have got the same base, AF, right? And they got the same area. The conclusion is that they've got the same height. Because the area of a triangle is half base times height. They got the same area and they got the same base, therefore they got the same height, which means that the point E, its distance from AC, that's the height, is the same as the distance from D to AC, that's the height. If you've got 2 points which are the same distance from a line, they have to be parallel. So these lines are therefore parallel, okay? We are given the area of the whole triangle. Original triangle is ABC. All right. Now we can use this ratio because AD is to DB is 2 is to 3. 2 parts, 3 parts. I'm not saying that these are equal to 2 and 2 centimeters, 3 centimeters. I'm saying 2 parts, 3 parts. And now you've got a parallel line here, right? And you have this theorem of the mean proportion, which says that when you've got a triangle and you've got a line which is parallel to the base, then the ratio of that to that is the same as the ratio of that to that. Right? It's called the mean proportion theorem. Some of you in grade 10 might not have seen it, but just know that this is a very simple theorem, very useful, that if you've got a line parallel to a third side of a triangle, it divides the remaining 2 sides in the same ratio. This over this is the same as that over that. Okay, so it also has a converse. All right, so knowing that, then we can say that this ratio here, this part is 3 parts and that part is 2 parts, right? But now this part here, BE, is interesting because it is a side of triangle ABE, and we need to find the area of this, right? So we need to find the area of ABE. So let's go ahead and try to put area ABE. Now the area ABE, okay, I know BE over EC, right? BE over EC is 3 over 2. That's BE over EC. Sorry, I'm squeezing this in like this. It's very badly. I promise I'm not going to rush through this. So let's do this thing properly. Use black for example. And now 3 over 2 is equal to BD over AD. That's the same as BE over EC. That's from the theorem, mean proportion theorem, which I mentioned. Now, another very important fact, which we have done in our classes, is when you got a triangle and you got a Servian, what I call a Servian, any line that joins a vertex to the other side. Right? When you got any situation like this, then the ratio of this to this is the same as the ratio of this area to this area. These two triangles have got the same height, you see. Right? They've got the same vertex here, so they've got the same height. So when you put this over this, it's the same as that area over that area if you make the calculations. So that allows me to say that the area, where are we? BE, the area of ABE over the area of AEC. Okay. So what have we got? We got that, I'm going to just look at this small picture here to illustrate what's going on. We've got the ratio of these two areas is 3:2. This is my ABE. This is the thing that I'm looking for. It's going to be 3:2. But we know the area of the entire thing, ABC, right? That was given as 450. So what do we know? We need to find the area of this. So in other words, we have to divide 350 into the ratio 3:2, right? And that's easy because then it's 3/5 and 2/5. So 3/5 of 450 is, so the area that we're looking for is 3/5 of 450. Because we're dividing 450 into the ratio 3:2. And when you do proportions in primary school, that is how you do this. 3/5 of 450, and 5 goes into 90. 3 times 90 is 270. So the answer to problem 24 is 270. Now again, it's a difficult problem, and you can understand why I took such a long time to solve this, to work this paper out. But anyway, they were very nice, interesting problems. Okay, so we go to this last one. The last problem is, it's actually this one here. Okay, problem 25, you got a factorial here, and you have to determine the largest positive integer such that 10 to the power of n is a factor of 1005 factorial. All right, so you got 1005 factorial, and you've got, what is this, 1 times 2 times 3, all the way into 1000 times 1005. Right. What is the question? The question is, you have to understand it. You want it to be divisible by 10 to the power of n, some power of 10. So in other words, I have to take all the factors of 10 out from here. But I want to get the largest possible power that can go into this, the largest power of 10. Certainly 10 is a factor. 10 is sitting here happily somewhere, and 20 and 30 and so on, even 1,000, right? So you've got quite a few 10s in it. But the 10s contribute to the product. But not only that, but the 5s also contribute, because the 10 is equal to 2 times 5. So every time you have 2 times 5, actually that will be the right way to do it. Each time you have 2 times 5, then you've got a 10, right? So I need to find the largest possible power of 10. So 10 to the power of n is 2 to the n times 5 to the n. Now, in this product, there are more 2s than 5s. Even numbers, the many more even numbers than multiples of 5. So I really need to work out all the 5s which occur in this. All those numbers which are multiples of 5. If I know the largest power of 5 that can go into this, that will be the same as the largest power of 10, because each of those 5s can be matched with one of the 2s. So the question is actually to find the largest power of 5 which goes into this. What is the largest power of 5 that is a factor of the above? All right, now, in other words, you need to count all the 5s here. How many times does 5 appear here? All right, now, your first answer would be, well, I got 5, 10, 10 is 5 times 2, 15, and so on, going up to this. So if you count how many 5s there are in 5, 10, 15, and so on to 2000, I'm sorry, 1005, it will be 1005 divided by 5. Right? Because these are all multiples of 5. So the number of 5s is 201. But we have to be a little bit cautious here, because some of these numbers have got more than one 5. A single, like 25, for instance, contributes 2 5s. See? So, but we only counted it once when we counted it in this 201. So we need to count the number of 5s, the extra 5s which occur in multiples of 25. So you have to look at all the multiples of 25, and the number of multiples of 25 in 1005, if you divide it, well, you can see 25 times 40 is 1,000. 25 times 4 is 100. So there are 40 multiples of 25. 25, 50, 75, and so on, going up to 1,000, and the 1,000 is the 40th multiple. So these all contribute 2s. Then we might want to stop there, but you'll think, but wait a minute, are there any which contribute 3 5s? Yes, 5 times 5 times 5, which is 125. That's amongst these, this large number of factors here. 125 is sitting somewhere. So we need to count the number of 125s, because each one of them contributes one more 5. And this contributes one more than that. It's contributes one more 5. So there are 8 of them. 125 times 8 is 1,000. Right, you might want to stop there, but just be a little bit careful, because you have to ask yourself whether 5 times 5 times 5 times 5 occurs here. 4 of them. And sure enough, this is 625, which is still less than 1,000. So there is one 625 which occurs, right? And the multiples of that are 12, 50, and so on, and that exceeds 1005. So there's only one here, okay? And you don't have 5 to the power of 5. That's gone too big, okay, as you can see. So the total number is simply, you add up all these things. Right? 8 plus 2 is 10. Oh, no, this is 200. I got 250. I don't remember that answer for some reason. Okay. It looks as if the answer is 250. Did I? Oh, 2 to the power, yeah, 250, right, okay. Okay, I didn't have to worry. Okay, guys, so that takes care of the last 5 problems. It took us 1 hour, 15 minutes to do those. And now we'll get on to the other 20 problems. Do them briskly. But before doing that, I want to, there are some problems earlier on. Let's do problem number 19 and 18 as well. Let's go backwards from 20. I don't know why my mouse is not. Okay. Sorry, there's something playing up here. Come on, mouse. Didn't give this mouse its cheese for breakfast. Okay, I found a solution. Sorry about this delay. Problem number 19. Let's have a look at problem number 19. This was also a nice problem, which I found quite demanding. Took quite a lot of time because I was doing the wrong thing. All right, now problem number 19 is about a chess game, or well, not a chess game, it's a chess tournament. And there are 8 participants. Right? These 8 participants, they play games, and the question says that they each one plays everybody else. Okay, that's the usual thing. And if you win, you get 1 point. If you draw, you get half a point. And if you lose, you get 0 points. Then what happens here is that it's also said that no 2 people, they all got different totals. The first 8 people have got different scores. There are no ties amongst the top 8 people who are participating. Right. Now, they give you 2 pieces of information. So let's just set up this problem. Now, each person, first, second, up to 8, has got so many points. What I'm going to do is I'm going to list those points in a vertical line, first, second, third, and so on, to put the highest at the top and the lowest at the bottom. All right, I'm going to use a space here. I'm going to use a whiteboard later on. First, second, third, fourth, fifth, sixth, seventh, eighth. Right. Now, we know that all these numbers are different, and this is in decreasing order. This is the first person has got more than the second, and so on. Right. A win is worth half a point, and a loss is worth 0 points. So each game, the total score for each game is 1, because even if they draw, they got half. So that's 1. Total score for each game is 1. So I'd like to know what the total scores are, because, okay, before that, we say the total score for the person in the second place is equal to the sum of the scores of the participants in the bottom 4 places. So this guy here has got the same as the sum of the these 4 bottom ones, right? The participant in the 8th place, he drew just 1 match and he lost the rest. So the 8th fellow, he only got half a point. His total number of points is half. Okay, so we got at least 1 score. The question is, what is the maximum score of the participant in the 5th place? The participant in the 5th place, we don't know this person's score, but we want to know the maximum possible score that this person can get. So let's just call that X. So we need to find the maximum value of X. How do we do that? Well, to get the maximum value of x, remember this is decreasing, coming down here like this, right? We have to get the remaining numbers as small as possible. Okay? So remaining numbers have to be as small as possible. So you must remember, half a point is allowed, right? Because you can't draw. So if the remaining points are as small as possible, then we'll have to have this to be 1, because all the scores are different. And this is 1.5 here, right? We want that to be as small as possible. Okay, it is also given that the participant in the second place is equal to the sum of the scores in the bottom 4 places. So when you add the scores in the bottom 4 places, 1.5 plus half is 2, plus 1 is 3. So you get x plus 3. Right? And the person in the second place has got his or her score is x plus 3. Right? Right, so to get the minimum now, we should really make this x plus half here and make this x plus 1. Right? We want the minimum of the other scores. Right. So this is where we are. The only question mark is about 1. What shall we put there? You can put x plus 3.5, but I'm going to hold on with that because I want to know something more. I need to get to an equation. Now, where is the equation here? The equation is in the total scores. You see, each game has a score of 1 point. Each game, we'll say equals 1. Right? Now, so how many games are there? The number of games will be the total. What's the total score? The total score will be the total number of games because each game has got 1. And that we can count because we know we got 8 people. And each one plays every other person. And we've done this before. The number of games is exactly the same as the number of ways in which you can choose 2 people from 8. The number of ways in which you can choose 2 people from 8. And we've done this in our lessons earlier on. The number of ways of choosing 2 people from n is n into n minus 1 over 2. So there are 28 games. If you wish, you can count all the games. It's not difficult to count it. First one plays 7, the second one plays 6, and so on and so forth. All right, so therefore the total score will be 28 when you add up all the scores. So let's add up all the scores. You got an unknown here. Let's call this y. So y plus, all right, let's add up all the x's. You got 1, 2, 3, 4. Okay, y plus 4x. 4x. And then the numbers are 4, 4.5, 6, 7, 7.5. Right? Okay, it's 4.5 plus 3, yeah. Okay, and that is equal to 28. But one important thing is that y is greater than x plus 3 because That guy has got more points than the second guy. So you got that this number here, right? 4x plus, if you put this 4x, bring this to the other side, 28 minus 7.5, it gives you 20.5. And you have that y is greater than x plus 3. The y is equal to 20.5 minus 4x. Right? 20.5 minus 4x is greater than x plus 3. You have to have that. And therefore, you will have, now you got an inequality involving x. So 20.5 minus 3 is 17.5. And that's greater than 5x. And 5x less than 17.5 means that x is less than 3.5. You want the largest possible value for x. And the largest possible value for x, which is less than 3.5, is 3. Remember, x is a score. So it's either an integer or integer plus half. So the answer to this problem is 3. Demanding problem, problem number 19. Can I just find out if anybody has got the answer 3? Wow, there were 3 people. 5 people got the answer 3. Very good. Excellent. Okay. Well, let's hope we get a couple of people in the top. Well, I'm quite certain there will be a number of people in the top 100. Let's go to problem 18 now. We said we're going to work backwards. Okay, problem 18 also a nice problem. You got 2 squares. Okay, you got a right angle triangle. 2 squares are inscribed differently in the same given isosceles right angle triangle as shown. So it's an isosceles right angle triangle, very important. So the angles are 45, 45, 90, right? And there's a square here and there's another square here. One square is drawn like this, another square is drawn like this. And they give you that the area of the first square, this area here, is 441. And you're asked to find the area of that square. Right? Interesting, very interesting problem. All right, so what I'm going to do is we'll analyze these problems. I'm going to go into my whiteboard because I don't have any space on this thing. Okay, let me just clear my whiteboard. Now, what we're going to do now is just repeat the diagram. You know, I spent such a long time moving this pen around. One has to be very adept in this. I forget what I am doing and so on. I seem to have lost something here. Sorry, just one moment, please. Let me just get back to this thing. Okay, I'm better off now. Okay, so I'm going to redraw these diagrams. This is isosceles, so I'll make these sides the same. And in the other case, we have okay. So we draw these. In one case, you've got a square. Like that. And the other case, you got another square drawn this way. I might not draw it very accurately, obviously. We don't know where to start here. But we have to pretend that whatever I'm drawing is a square. All right, now these are both squares. And these are isosceles triangles. So let's say the side of the square here is A. Suppose the side of the square is A. Right? And the side of the square here is B. Right. I want to find out what the relationship. The square here has got area 441. And I need to find the area of the square here. So I need to find B squared, in other words. That's the goal. All right, if this is a square, then this is A. This is A, and that is A. Now remember, it's an isosceles right angle triangle, so this angle is 45 here. And this is 90 degrees, so this is also 45. So you've got, this thing here is also an isosceles triangle, and so is this one here. It's 45 there. Okay, so that is the picture that we get in this diagram. In this diagram, what picture do you get? You get, this is B here, and this is B here, and that is B because that's a square. Right? But again, you got 45 here, and this is still 90 degrees. So this is an isosceles triangle here. The 45 is here now. So you got a B here. And likewise, there's a 45 here, and this is 90. So this angle is 45. So this is also an isosceles triangle, right? So there is a relationship between the two, right? If you look carefully, you'll see that I can calculate the hypotenuse of this triangle in two different ways, right? The hypotenuse squared, h for hypotenuse, on the one hand is 2a, so it's 4a squared plus 4a squared. On the other hand, it's 3b all squared. Right. But we know what a squared is. A squared is 441. So you got 8 times 441 equals 9b squared. So the b squared, you simply have to divide by 9 on both sides. 441, 9 goes exactly into that, 49 times. It's 392, and that's exactly what we needed to find, the area of the square. Okay, how many of you got 392? Hopefully we've got more people. I'm happy to see that there is a fair number of people who are solving these tough problems. And the fact that you went all the way up to this problem is also very encouraging. Okay, let's get on to problem 17 since we are working backwards. I'm going to go back to my old screen. All right, so problem 17 says every child in the school has one or more unique numbers for the school's lucky draw. The numbers start at 1 and continue up to 1,000. All right, so you got 1,000 numbers, but it starts from 1. So it goes up to 1,000. So there are 1,000 numbers altogether. What is the probability that the first number drawn at random has no 7s and no 9s amongst its digits? All right, so you can draw, like, in other words, let's just analyze what the question says. The question says that you are drawing any one of these 1,000 cards, and you can pick up a number like 656. Okay, it has neither 7 nor a 9, so that's allowed. But if you pick out 788, we disallow that. So we take out all those numbers from 1 to 1,000, which has got either a 7 or a 9. A 7 or a 9. It's got no 9s, no 7s, right? So we remove those numbers. And then we say, okay, how many such numbers are there? And then our probability, the question is, what is the probability? The total number of possible numbers is 1,000. So we count whatever we've got, we put it over 1,000, and that will be the probability. But they are asking, yeah, okay. Or multiplied by 1,000. All right. So in other words, we just want to know how many such numbers are there, right? Because if you multiply by 1,000, you'll get the numerator. Okay, so the way to do this is, well, how we need to count, and you got a 3-digit number. There is a 4-digit number, that is 1,000, and the number 000 is excluded, right? But maybe I can think of 000 as being 1,000. Then in that case, I can just think of 00 as representing 1,000, right? So I'll include 000 in this count. So I can have any number from 0 to 9 here. Oh, like a number like 6 will be 006. 35 will be 035. So we can add a 0 with the hundredths unit and the tens unit and the units are all included. So the question is now, how can we choose these numbers so that we have no 7s and no 9s? Now, you can choose the first number in 10 different ways generally, 0 up to 3, 0, 1, 2, up to 9. But we're not allowed to put 7 and not allowed to put 9. So we can choose the first number in 8 different ways. Right, now before I go on, what we are doing here is what we did when we were working out problems on probability and counting. And we are going to use the second counting principle. In other words, I want to count how many numbers there are. And we say, we put them in a block as I'm doing here now. And we say, well, in how many ways can I fill this first one? In how many ways can I fill the second one? In how many ways can I fill the third one? And we multiply all of them together. That's the second counting principle. The first counting principle has only got 2 blocks. Now, how many ways can I do the first? Choose the first one and the second one, and you multiply the 2 together. The second counting principle does not restrict it to two blocks. So the way, it's a very easy way to count things is to do it like that. You say, in how many ways can I fill this one? 8 ways. Even this to 8 ways. Even this to 8 ways. In each case, the 5 and the 7 have been neglected. So therefore, the total number will be 8 times 8 times 8. That's 512. Right? And the probability, as I said, is 512 over 1,000. But when you multiply it by 1,000, you're going to get 512, and that's the answer. Right, so problem number 17. How many of you can happily say that you've got the answer to that question? $512. Okay, so it seems that not many of you got this. I think probably you're scared of probability. It's I think people get frightened when you want to count. Now, all of you should go to my book and go read the entire lesson on counting. I have a whole lesson on counting. It gives you all the techniques of counting. There are some very difficult ones, but just go as far as you can. But from the beginning, go through it, because I explain everything quite nicely. And you will learn quite a lot about probability and counting in that, and it'll prepare you for grade 12, because there's a whole section on probability in grade 12 paper. So go to my book and you will be able to see, learn quite a lot. We go to problem number 16. It looks like a geometry problem. So what is the size of the angle that is formed by extending 2 sides of a regular nonagon? Oh, this is a nonagon. Yeah, we hardly come across nonagons. Pentagon, sexagon, septagon, hexagon, and so on. Nonagon is a 9-sided figure. And 2 of these sides are extended. And the question is, when they eventually meet, what is the angle formed by the 2? So that looks like quite a nice, challenging problem. Okay, this is a regular nonagon. And we've spoken about regular polygons. One important thing about any polygon, we've said, is that the exterior angles add up to 360 degrees, all the exterior angles. So in a regular polygon, all the exterior angles, all the interior angles are equal. So therefore the exterior angles will also be equal, and they all add up to 360 degrees. So you've got 9 equal angles here. This is a nonagon. 9 equal angles, which add up, exterior angles, which add up to 360 degrees. Why exterior? Because I can see two exterior angles here. I want to calculate these exterior angles. So each exterior angle is equal to 40 degrees because it's 360 divided by 9. These 9 exterior angles add up to 360. They're all equal. So these angles are both 40. Right? So one of the ways of doing this is, I just saw a much easier way than the one that I had found. So I'll give you 2 solutions. I just discovered this now while I was looking at it. One of the ways of doing this is to join these 2 points. Right. If I know these 2 angles, then I got that angle which I can't see. So I need to calculate these 2 angles. Now this is a regular polygon. So all the angles, internal angles, are equal. So, and what are they equal to? If the exterior angle is 40, the interior must be 140. 140. 140. Okay, so now we need to work out these 2 angles. They are evidently equal. And you got that, in fact, you can kind of see that they are parallel. We shouldn't assume that, but anyway, you got the 4 angles, even if you don't assume they are parallel, you got for these 2 angles add up to 280. And the other 2 angles will add up to 360 minus 280. So therefore, these 2 angles here add up to 80, but they are equal. So each must be 40, which means that that angle is 80, that angle is 80, and the other angle must be 20. 80 plus 80 is 160. So the third angle will be 20. Okay. I did it in another way. When you get the solutions, you will see the other solution, which is a little more. Yeah, I'm making an assumption here that these angles are equal, this 40, 40. My solution, the other solution does not make any assumption. But our intuition tells us that these are 40. So you could come to that answer. Not a perfect answer. We can prove that they are 40, but it'll take a long time. Okay, let's get to another one. The next problem, which is going to be problem number 15. Okay. It's another tricky problem. I suspect that the highest mark in the country would be not more than 20 out of 25, because many of these problems are quite difficult. I'm assuming that other people found this problem paper as difficult as I did. There may be some people who will get more than that. Many good students in this country. Some of them are amongst you. All right, so the committee has 4 meetings. And at each meeting, there are 3 attendees. So there are exactly 3 people who attend any given meeting. No 2 committee members attend more than 1 meeting together. So if 2 people attend a certain meeting, they wouldn't attend in those 4 meetings. If 2 people attended one of those meetings, a pair, they wouldn't be appearing as a pair in another meeting. That's what it says here. What is the least number of members that can be on the committee? All right, now this one here is also a rather tricky problem, but when you start thinking about how to solve it, the idea comes that let's just make a triangle to show the three people who are at the first meeting. So this is your first meeting. So these three people, the people are at the vertices of this triangle. Right. Now let's get to the second meeting. Now the second meeting, you want the least number of members. So that can be on a committee. Okay, so I want to reduce the number of members in this committee. So let's try to choose members from this committee here for the second meeting. You cannot choose two. So you can only choose one. So let this person be in the second committee meeting. And I'm going to draw the second committee meeting in red. All right, so now you will need 1, 2, 3, 4, 5. You need at least 5 people to attend 2 meetings. But you will need to attend 4 meetings altogether. All right, so let's get on to the third meeting. Okay, let's choose. For the third meeting, you can choose exactly one from here and exactly one from here. You're not allowed to choose more than one. Right? And we want the least number of members, so we will choose one from here. We'll choose one from here. That makes 2. But then we can't choose, we need a third member. So we'll have to have a third guy. So let's just suppose we choose those 2. And I'll color it differently. So you choose this guy, that guy, and then one other person. So you got the 3 meetings in 3 colors. It took me a long time to draw up this scheme. I must say, I don't know what to do, but it helped a great deal to do it like this. And now you got 6 people, 1, 2, 3, 4, 5, 6. Right. So now those 3 meetings, and you got all the people who attended those 3 meetings. Now for the fourth meeting, yes, I can choose one from each of these triangles, right? So there are no repetitions. And how do you do that? Well, I can't choose this or this. I'll choose that fellow. Choose this fellow from the third meeting. Oh, let me just pick a nice color. Yes, some lovely, beautiful colors here. Okay, so you've got blue for this. Choose that fellow, that person from that committee, this person from this committee, and this person from this committee, right? And those 3 can form your fourth meeting. So you cannot do it with 5, but you can do it with 6. So the least number is 6. The answer is 6. Okay, let me see now how many of you got this answer? Mr. Basson, you did well. to get this answer? Those people who have studied the subject called graph theory would be better equipped to solve this problem. But I don't know much about graph theory, so I had to struggle along. When I was a student, graph theory wasn't invented. Okay, now let's get a problem number 14. A man can commute either by train or by bus. If he goes to work by train in the morning, he comes home by bus in the afternoon. And if he comes home in the afternoon by train, he took the bus in the morning. In a particular month, the man took the bus to work in the morning 8 times, came home by bus in the afternoon 15 times, and commuted by train 9 times. How many days in this month does the man work? This looks like a really horrible problem. Okay, let's just see, let's unpack the thing. There's so much of verbal abuse. Excuse me. Verbal abuse, I say. You have to read through so much. Okay, he either takes a train or a bus in any given trip. So in the mornings, sometimes he takes a train or a bus, and in the afternoons he takes the bus or the train. All right, so you know, the solution which is given, I've got solutions from those who set the paper. They didn't notice something which is very simple here. I can work out the solution very easily. If you say, talk about morning and afternoon. So in the morning, and the afternoon, right? In the morning, he takes the bus or the train. In the afternoon, he takes the bus or the train. The total number of days in the month that the man works, each day, he uses two modes of transport. So the number of modes of transport that he uses altogether is twice the number of days he travels. So there is a connection. So I need to know how many modes of transport did he use, right? Now he used a bus in the morning, a train in the afternoon, bus in the morning, bus in the afternoon, train in the morning, train in the afternoon, or train in the morning, bus in the afternoon. But essentially, we need to know how many times did he use the bus and how many times did he use the train altogether. Now, the number of times he took the bus in the morning is 8 times. The number of times he came back in the afternoon by bus was 15 times. So the total number of times he used the bus is 8 plus 15. And now they tell you he commuted by train either in the morning or the afternoon 9 times. So altogether he used the train 9 times. Right? So the total number of transport modes he used was 8 plus 15 plus 9. That gives you, and each day he uses exactly 2 modes of transport. So the number of days is that. So the answer is 16. The people who set the question didn't see this. rather beautiful solution. And I too, it took me a long time. But anyway, you see, this information they use like this. They say, it's a subtle thing. They tell you if he goes to work by train in the morning, they tell you what happens in the afternoon. And then it tells you if you took the train in the afternoon, it tells you what happened in the morning. But it doesn't say what happens if you took the bus in the morning, no conclusion. Or if you took a bus in the afternoon, no conclusion. That is a very subtle thing in this problem. And I think they were trying to extract that to see whether the students were able to see that you can make no conclusion about whether you took a bus in the morning. If you took a bus in the morning, no conclusion. But if you took a train in the morning, you can make a conclusion. So, but actually we didn't need all that from my solution. So we'll just ignore the subtleties of this problem. And we are now at 3 minutes past 11, and we've done 14 problems out of 25. And we've still got 13 problems to go. And we've done the 14 more difficult problems. I am going to arrange for a meeting for the first 13 problems. And those people who want to come to that can come along. But I will be recording that as well. So we'll have 2 recordings for this exam, which we're calling the 2021 Round 2 Senior Exam. So we'll close here, and hopefully all of you come back, all 17 of you come back, so you can see how many you have got from the first 13. It's very important for you to know how many you got there, because very few people would have got these rather frightening problems. So you'll need to know what score you got in this. And you can tell others as well, because this time they wouldn't be put off. We are going to do the easier problems, and we probably will finish in 1 hour, hopefully, or less than an hour. Okay. All right, guys. If you got any comments, please put it down in the chat column. And hopefully I'll see you again. But we will now close this session. We won't close it. I'll just close my recording, and we can talk if you want to thereafter.